As twilight deepens, a celestial beacon emerges in the night sky. It's Venus, our closest planetary neighbor, blazing brighter than any star. Ancient civilizations marveled at its brilliance, calling it the morning star or the evening star. Venus captivated early astronomers, a celestial enigma shrouded in a thick, impenetrable veil of clouds. Venus and Earth, born from the same cosmic cloud, started as planetary siblings. They share a similar size, mass, and composition, hinting at a shared history. Yet their paths diverge dramatically, leading to two vastly different destinies. Earth teems with life, its oceans, continents, and atmosphere, a testament to the delicate balance that sustains us. Venus, on the other hand, tells a different tale. It's a story of runaway climate change, a planet trapped in a perpetual greenhouse state. What happened to Venus? The answer lies in its atmosphere and tumultuous history. Our story begins billions of years ago, in a corner of the Milky Way galaxy. A giant cloud of gas and dust swirled under the pull of gravity. This cosmic dance ignited nuclear fusion, giving birth to our Sun. Around this newborn star, a swirling disk of material began to coalesce, forming planets, including Earth and Venus. In these early days, the solar system was chaotic. Planets jostled for position, their orbits shifting and changing. Asteroids and comets rained down, leaving scars that still mark their surfaces. Amidst this turmoil, Venus and Earth were taking shape, their destinies intertwined yet distinct. 9. But here we encounter a cosmic puzzle. The young Sun was significantly dimmer than it is today. Scientists estimate that the early Sun emitted up to 30% less energy. This presents a paradox. If the Sun was so faint, how could Venus have been warm enough for liquid water? This conundrum, known as the faint young Sun paradox, has puzzled scientists for decades. One possible solution lies in the composition of Venus's early atmosphere. Scientists theorize that the early Venusian atmosphere contained much higher levels of greenhouse gases, such as carbon dioxide and methane. These gases are incredibly efficient at trapping heat. They act like a blanket, preventing solar radiation from escaping and warming the planet. With a thicker atmosphere and higher levels of greenhouse gases, Venus could have maintained a temperate climate, warm enough for liquid water. Imagine a world shrouded in perpetual mist, its skies a hazy yellow, its surface sculpted by rivers and lakes. The Sun, though dimmer, would still have provided enough energy to drive a water cycle. This period of potential habitability, however, was balanced on a knife edge. The very factors that allowed Venus to maintain a temperate climate also made it incredibly sensitive to change. A slight shift in the balance could have set in motion a chain reaction with catastrophic consequences. The idea of oceans on Venus might seem like science fiction, yet there's compelling evidence to suggest that this scorching world may have once harbored vast bodies of water. Scientists have found clues in Venus's atmosphere and geological features that point to a wetter past. One compelling piece of evidence comes from the study of Venus's atmosphere. Venus's atmosphere contains traces of deuterium, a heavier isotope of hydrogen. The high deuterium to hydrogen ratio suggests ancient oceans. Over time, water lost to space increases this ratio. Venus's high ratio indicates it may have had a global ocean lost over billions of years. Early Venus may have possessed all the necessary ingredients for life. Life requires liquid water, a source of energy, and a stable environment. Venus, during this early period, may have offered all three. Imagine waves crashing against volcanic coastlines. The sky, a hazy yellow, casting a warm glow on the landscape. Microbial life teeming in the shallows, harnessing energy. We have no direct evidence of past life on Venus. The intense heat and pressure likely erased any traces. If life did arise on Venus, it would have profound implications. While the young Venus may have enjoyed a period of relative stability, A ticking clock was already counting down to a dramatic shift. The same forces that initially allowed Venus to maintain a temperate climate, its thick atmosphere and abundance of greenhouse gases, would ultimately lead to its demise. As the sun continued to mature, it gradually grew brighter, emitting more energy into space. This increase in solar radiation, though gradual, had a profound impact on Venus. The planet's thick atmosphere, rich in carbon dioxide, acted like a trap, absorbing the sun's heat and preventing it from escaping back into space. Temperatures on Venus began to rise, slowly at first, then at an accelerating pace. As temperatures climbed, a vicious cycle began. The warming oceans evaporated at an increasing rate, adding more water vapor to the atmosphere. Water vapor itself is a potent greenhouse gas, further trapping heat and amplifying the warming effect. This process, known as a runaway greenhouse effect, pushed Venus further and further away from its once temperate climate. The rising temperatures also had a devastating impact on the planet's surface. Volcanoes, fueled by the planet's internal heat, erupted with renewed fury, spewing more carbon dioxide and other greenhouse gases into the atmosphere. These eruptions, combined with the increasing solar radiation, created a feedback loop, driving temperatures ever higher. Venus was trapped in a spiral of its own making, a one-way street to becoming the inferno we see today. The story of Venus's transformation from a potentially habitable world to a scorching wasteland highlights the delicate balance that governs planetary climates. It underscores the interconnectedness of a planet's atmosphere, its oceans, its geology, and its distance from its star. A slight change in any of these factors can have cascading effects, tipping a planet towards or away from habitability. Venus's fate serves as a stark reminder of the fragility of our own planet. While Earth's climate is relatively stable, it is not immune to change. The rapid increase in greenhouse gases in Earth's atmosphere due to human activity is already causing our planet to warm, leading to rising sea levels, more extreme weather events, and other disruptions to the delicate balance of our biosphere. Venus stands as a cautionary tale, a warning from our closest planetary neighbor. It reminds us that the choices we make today will have a lasting impact on the future of our planet. By understanding the forces that shaped Venus's destiny, we can gain a deeper appreciation for the preciousness of our own world and the importance of protecting it for generations to come. As the sun grew brighter and Venus absorbed more heat, temperatures on the planet began to climb. This runaway greenhouse effect transformed Venus into a scorching inferno. Imagine Venus in those early days, its oceans beginning to simmer. More water evaporated, creating a thick, steamy blanket around the planet. Water vapor, a powerful greenhouse gas, trapped heat even more effectively. This created a vicious cycle, amplifying the heat over time. As the runaway greenhouse effect took hold, Venus underwent a dramatic transformation, its once familiar features disappearing beneath a shroud of heat and toxic gases. The oceans, once teeming with the possibility of life, vaporized entirely, leaving behind dry, salt-encrusted basins as a stark reminder of their former presence. The planet's atmosphere, once perhaps cloudy but still relatively hospitable, became a thick, choking blanket of carbon dioxide, laced with sulfuric acid clouds. These thick clouds, reflecting sunlight back into space, gave Venus its high albedo, making it appear as the brightest object in our night sky, a beacon of what was, rather than what could be. Volcanic activity, already intense on early Venus, likely increased as the planet's interior heated up. Volcanoes erupted with renewed fury, spewing lava flows across the surface and injecting even more carbon dioxide and sulfur dioxide into the atmosphere. Some scientists believe that these large-scale volcanic eruptions may have played a key role in triggering or accelerating the runaway greenhouse effect. Without the moderating influence of oceans, temperatures on Venus soared to unimaginable levels, eventually stabilizing at a scorching 900 degrees Fahrenheit, or 475 degrees Celsius. This intense heat, combined with the crushing atmospheric pressure, created a surface environment unlike anything found on Earth. A hostile and unforgiving wasteland where even the most durable spacecraft would melt and crumble within hours. Today, Venus stands as a stark reminder of the power of the runaway greenhouse effect, a cautionary tale of a planet pushed to extremes. Its surface, hidden beneath a perpetual shroud of thick, toxic clouds, is a desolate wasteland, a testament to the devastating effects of unchecked climate change. The intense heat on Venus is relentless, baking the surface and creating vast plains of volcanic rock, twisted and deformed by the planet's internal heat. The atmospheric pressure, 90 times greater than Earth's, is equivalent to being 3,000 feet beneath the ocean's surface, a crushing weight that would instantly kill any unprotected life. The thick atmosphere, primarily composed of carbon dioxide, traps heat with incredible efficiency, creating an oven-like environment where temperatures remain relatively constant day and night, regardless of location. The clouds, composed of sulfuric acid droplets, rain down a corrosive acid rain, although the rain evaporates long before it reaches the surface due to the intense heat. The extreme conditions on Venus make it one of the most challenging destinations in our solar system for exploration. Spacecraft sent to study this enigmatic world must be designed to withstand the intense heat, pressure, and corrosive atmosphere, limiting their operational lifespan to mere hours. Yet despite these challenges, scientists remain determined to unlock the secrets of Venus, to understand how this once promising world transformed into the inferno we see today. As Venus succumbed to the relentless grip of the runaway greenhouse effect, it also lost its protective magnetic field. This shield, generated deep within a planet's core, protects its atmosphere from the solar wind. Earth deflects most of the solar wind, creating a safe haven for life. But Venus lacks this barrier. Without it, Venus was vulnerable to the solar wind, stripping away its atmosphere. The solar wind relentlessly chipped away at Venus's atmosphere, targeting hydrogen first. Hydrogen, the smallest and most abundant element, is highly susceptible to escape. Each gust of solar wind stripped more hydrogen from Venus's upper atmosphere. This loss had a cascading effect on Venus's atmosphere. Water molecules broke apart, oxygen either escaping or forming oxides, contributing to a dry environment. The atmosphere became dominated by carbon dioxide, trapping heat and fueling a runaway greenhouse effect. This process unfolded over billions of years, transforming Venus's atmosphere. Like a sculptor, the solar wind reshaped Venus's atmosphere into the thick, toxic blanket we see today. The contrasting fates of Earth and Venus, two planets born from the same cosmic cradle, highlight the crucial role that a magnetic field plays in protecting a planet's atmosphere and its potential for life. Venus, on the other hand, tells a different story, a cautionary tale of what can happen when a planet loses its protective shield. Transformed Venus from a potentially habitable world into the inferno we see today. The story of Earth and Venus is a tale of two atmospheres, a complex interplay of factors that can tip a world towards or away from life. The surface of Venus, a scorching hellscape, seems like the last place you'd expect to find life. But what about high above that desolate landscape, in the cooler layers of Venus's dense atmosphere? Could life find refuge in the Venusian clouds, a glimmer of possibility in an otherwise unforgiving world? Temperatures in the upper atmosphere, around 50 to 60 kilometers above the surface, are surprisingly mild. Of course, these upper layers are still far from hospitable. The clouds are primarily composed of sulfuric acid droplets. However, life on Earth has surprised us with its ability to adapt and thrive in the most extreme conditions. Could extremophiles exist in the Venusian clouds, eking out a living in this alien sky? In 2020, a team of scientists made a startling announcement that sent ripples of excitement through the scientific community and captured the imagination of the public. Using telescopes to observe Venus's atmosphere, they had detected the faint signature of a gas called phosphine. On Earth, phosphine is often associated with life, produced by microorganisms in oxygen-poor environments like swamps and sewage treatment plants. While phosphine can also be created through certain industrial processes and by some geological activity, the amounts detected in Venus's atmosphere were far greater than could be explained by any known non-biological sources. The discovery of phosphine in Venus's atmosphere sparked intense debate and speculation. Could this be a sign of life, a biosignature hinting at the presence of microorganisms floating in the Venusian clouds? Or could there be another, as yet unknown, explanation for the presence of this enigmatic gas? The scientific community, as always, responded with a mix of cautious excitement and healthy skepticism. Extraordinary claims, after all, require extraordinary evidence, and the detection of phosphine, while intriguing, was not definitive proof of life. Scientists urged caution, emphasizing the need for further observations and independent verification. The discovery of phosphine in Venus's atmosphere, while still debated, has reignited interest in this enigmatic world and the possibility that it might harbor life. Scientists are now eager to take a closer look, to probe the Venusian clouds for further clues, and to unravel the mystery of this unexpected gas. Several missions to Venus are currently in development, including NASA's Veritas and Da Vinci Plus missions and the European Space Agency's Envision mission. These missions will use advanced radar, spectroscopy, and other instruments to study Venus's atmosphere, surface, and interior in unprecedented detail. These missions hold the potential to revolutionize our understanding of Venus, providing crucial data to help scientists determine the origin of phosphine and whether it might indeed be a sign of life. They will also shed light on Venus's past, helping us understand how it transformed from a potentially habitable world into the scorching inferno we see today. The story of Venus, once a tale of runaway climate change and planetary demise, has taken an unexpected turn. The possibility of life in the Venusian clouds, however remote, has injected a glimmer of hope and wonder into our exploration of this enigmatic world. Venus, it seems, still holds secrets that might just rewrite our understanding of life's limits and the possibilities for life beyond Earth. As we gaze at Venus, blazing like a diamond in the evening sky, it's a stark reminder that beauty can conceal turbulent secrets. Venus, once a potential twin of Earth, now stands as a testament to the fragility of planets, a cautionary tale whispered across the cosmos. The runaway greenhouse effect that gripped Venus, transforming it from a possible paradise into a scorching inferno, serves as a stark warning for our own world. Though separated by millions of miles, Earth and Venus share a common origin, their early histories intertwined in the swirling dust and gas of the nascent solar system. Yet their paths diverged, leading to two vastly different destinies. Understanding why Venus, our sister planet, succumbed to such a fate may hold the key to safeguarding Earth's future. The quest to understand Venus, to unravel its secrets and decipher its past, is far from over. Each new mission we send, each tantalizing piece of data we gather, brings us closer to comprehending its destiny and its potential for harboring life. Future missions, equipped with advanced instruments, will pierce the thick Venusian atmosphere. They'll map its surface, analyze its atmosphere, and search for signs of life. The exploration of Venus is a journey of self-discovery, a reflection on our place in the cosmos. Remember the lessons it holds and the enduring quest to unravel its mysteries.